Hi everyone. In this video, we will see how to set up load balancer in OCI. Now, before jumping to OCI console, let's understand some of the features of load balancer. So load balancer is a high availability regional service, just like object storage we have seen in our earlier video. So load balancer basically automates the distribution of incoming traffic to the backend compute instances that you provision. So if you see in this diagram, I have incoming traffic coming to my load balancer, and it is distributing that traffic to the backend set of compute instances, that is app1 and app2. Now, whenever you create a load balancer, you have an option to configure it in a public subnet or a private subnet. If you create it in a public subnet, Oracle automatically assigns a floating public IP to your load balancer. Now, another thing to note here is whenever you configure a load balancer, a standby instance is automatically created. If you create a load balancer in a single AD region, then it will be created in the same AD or at the same region. But if you are provisioning it in the region which has multi-AD capabilities, if there are more than one ADs to provision, a standby will be created in a separate AD. This is basically to ensure that whenever in a worst case scenario, if a primary load balancer goes down, standby takes over and starts the distribution of the traffic to the backend set. Now, if I talk about the high level architecture of the load balancer, you have a listener at the front that listens to the incoming traffic, and this gets routed to your backend set. Along with this listener and backend set, the thing to note here is the health check policy and the load balancer policies. So what health check policy do is it continuously monitors the health of your backend compute instances. And if in a scenario where, let's say, app1 goes down, app2 is the only source of distribution for your load balancer. But load balancer, through its health check policy, will continuously monitor the health of your backend compute instances. Now, how the traffic is routed between these two compute instances, for example, in this scenario, is decided by the kind of load balancer policy you set up. In case of round robin policy, the traffic gets toggled between app1 and app2. In case of IP hash, what load balancer does is it hashes the incoming IP and then decides what sort of compute instance the traffic need to be navigated to. In case of least connections, the load balancer will see which is the available compute instance that is not heavily utilized, and the traffic will be routed to that respective compute instance. In case of weighting policy, you basically decide you give the weightage to the compute instances, and depending on the weightage that you have given, load balancer will route that respective traffic. Now, another important thing to note here is, or to remember here is, the kind of encryption that load balancer will do. So the kind of encryption it supports will be decided by the SSL support you provide when you configure the instance. In case of front-end SSL, the incoming traffic till load balancer will be encrypted, and then onwards it will be unencrypted. For the backend, it will be the other way around. And for end-to-end SSL, the traffic that is coming to load balancer and that is going out of load balancer will be encrypted end to end. Now, in case of unencrypted traffic from load balancer to your compute instances, we will need to use HTTP with port 80. So port 80 has to be opened. But in case of encrypted traffic, it has to be HTTPS with 443. Now for this demo, we will go with unencrypted traffic from load balancer to your application subnet. So first thing we will need to do is we will have to, configure or enable the web server and configure or open the port 80. So let's jump to OCI console, and then I'll show you how to basically open the port 80 and start using this 80 for your unencrypted traffic from load balancer to application subnet. So if I go to my OCI console, I have two application compute instances running in the private subnet and the Bastion that is running in the public subnet. So first I will connect to this public compute instance, that is Bastion, with the public IP that you see over here. So I'll open my putty, I'll connect to Bastion, and then I'll do SSH into my app1 instance. So I'll do SSH into 10.0.0.25. Okay, now the next thing to do is I have to basically install the Apache web server. So I will write some command. I'll use the yum install here. So this installation will take a bit of time. So let's wait and let's see what sort of steps it is doing. So this could take up to a minute. Okay, it is moving fast. Let's see how much time it takes. So here basically I'm installing the Apache web server. Okay, great. It completed pretty quickly for me. Let me TL. I'm basically enabling this. And then now I need to open the port. So I will go with sudo firewall cmd add service equal to http. So basically I'm opening the port here. Okay, so you should see the message as success. If you are getting some issue, you need to check the command you are firing. There could be some syntax issues. CMD. I'm reloading the same. Great. So now I will try to see whether my default Apache page opens or not on the local host. Okay, let's see why it is giving this error. Okay, okay, this error is coming with port 443 because I have given HTTPS. We have to do HTTP because we are dealing with uh, port 80, unencrypted traffic. Great. So this is the default Apache page that you will see. Now what I'm going to do is I'll basically customize this and I'll give a custom message instead of displaying this custom web page to the user. So for that, let me go to root user. Hello, I'm just giving some dummy um, what to say dummy message where HTML and index.html. Okay, let me change the syntax. I think where okay, some syntax error I'm doing. Let me try. Let me change it again. If okay, great. So there was a slash that was missing. Now I'll basically just see what is the message that will be displayed. So basically, instead of displaying the default Apache home web page, I'm displaying the custom message. And how it will help is something that we will see when we will configure the load balancer. Okay, so if you see, it is showing hello, welcome to app one. And now this hostname app one is because we have done this configuration for application one. Now let me, I'll exit and do the same process for my application two. So now I will do SSH into my application two, which is with IP 10.0.0.20. So, okay, let me open another putty. And I'll do SSH over here. SSH 10.0.0.20. Okay, now we will do the same commands. I'll basically install the Apache server. I'll do yum install for that. Remember, this is something that we are doing on app 2 now. Before this, we have done the same thing for app 1. So hoping that it would complete pretty quickly like it has happened for app 1. So I'll not pause this video. Let's continue with the steps. All right, because this is taking a bit of time, which it is expected to, because it is doing all sort of installation in the backend. Let me quickly pause this video and come back when I will do the next steps about on the port opening and all. All right, so installation is done now. Let's proceed with the next steps. So this is system city. You enable now httpd dot service. Then I'll open the port. So firewall cmd add service equal to http. Okay, some sort of error. So there will be some syntax error. Let me check the command. Sudo firewall cmd. Okay. So what happened is I have missed one dash over here. Okay, so it is showing success. Now I will reload this page. Okay, great. Now I will do the curl command again to open the Apache default page on HTTP local host. Great. Now I will customize this just like we did for application 1. So I'll switch to my root user and I'll type the command echo hello welcome to dollar host name slash where www html index.html. Great. Now let's see whether it is displaying the correct message. Where www./html slash index.html. Okay, again, I think some syntax error I have missed. Okay, I gave extra W over here. Great. If you see, I have welcome to app 2. Now the mistake, there is a typo here. I have missed a small m here, but it's okay. The idea is basically to display a custom message instead of using the default Apache web page. So now what I have done is I have basically installed a web server, opened the port 80 that we will be using for our unencrypted traffic between the load balancer and the application that are residing in the private subnet. Now the next step we will do is we'll set up the load balancer. So I'll minimize this. I'll go to my networking load balancer. But before load balancer, I'll need to create a subnet. So I go to virtual cloud network. I'll have to create a public subnet to host that load balancer. Let me check if that is available. So there are only application subnet and western subnet. So let me create a subnet for my load balancer. So I'll give it as front end load balancer subnet. I'll give the CIDR block of 10.0.0.32-28. So it gives me 16 IPs to use because I need to create it as a public subnet. I'll keep rest of the configuration as is. Okay, so this is provisioning. Let me refresh the page or reload this page to see whether the provisioning is complete or not. Okay, so the front end load balancer subnet is now available. Now the next thing we have to do is we have to create a security list that will allow the incoming traffic from the internet to this subnet and outgoing traffic from this subnet to my application subnet and Bastion subnet, which is hosting the basically the application subnet that is hosting the compute instances. So I'll go to security list. I'll create a new security list. I will name this as security list for my load balancer. I need to allow the incoming traffic over port 80. So I'll give 0000 slash 0 on port 80. And I need to define two egress rules. First is 10.0.0.0 slash 28, which is nothing but a IP of my Bastion subnet. And I need to define another egress rule to go it to the application subnet. So IP of the application subnet is 10.0.0.16.28 and the destination port is 80. And I'll click create security list. So I'll open the security list again. Egress rules. One is for my Bastion subnet and one is for my application subnet. Let me just go to the diagram and verify it again. Bastion subnet is 10.0.0.28 and 10.0.0.16.28. Correct. Now, I will also need to ensure that I allow the incoming traffic from this subnet to my application subnet. So what I will do is I'll go to my security list for private subnet and okay, so this is already there. This is what I'm trying to say, that whatever outgoing traffic you are pushing from the load balancer, it has to come into your application subnet. So this ingress rule you need to define. So once this is done, I'll go to my VCN and I'll configure the load balancer now. I'll create a default load balancer. I'll give it a name as simple LB. I'm choosing the visibility type as public and I'm keeping the ephemeral IP address instead of the reserved IP address. Now, two options here you will see whether you want to select a flexible shape or a dynamic shape. Dynamic shape is helpful where you want to handle the heavy incoming traffic that could come during a particular season. So you would have seen that certain websites, certain retail websites would see a heavy incoming traffic during seasonality where there is a lot of purchase from the retail customers. So in such situations where you automatically want to handle that kind of volume, you can go for dynamic shape. For this demo, I'm just going with the default configuration. So I'll go to next. Okay, I need to select a VCN. I'll select a VCN. In the subnet, I'll select the front end subnet that I created for load balancer. Now here you have to choose what sort of load balancing policy you want to give. So we have already discussed this at the start of this session. What is the difference between weighted round robin, IP hash, and list connection? I'll go for the weighted round robin. I'll need to add the backend, the compute instances. I'll go for application 1 and application 2 that we have created. And what I need to do is I need to check specific or specify health check policy section. Now here, if you remember at the start of the session, I had told you that load balancer will continuously monitor the health of the compute instances. That is done using this configuration. So here, as per the configuration that you see, it will continuously try to see the health at every interval of 10,000 millisecond, and it will do 3 tries before displaying the health. And what you also can do is you can increase this configuration, decrease this configuration, like number of retries, timeout configuration, the interval at which you want your load balancer to monitor the health of the backend compute instances, and specify any custom path or message that you want to display. So for now, what I'm doing is I'm basically keeping the default configuration, and I'll click on next. Here I'll give the listener name as listener 1, and I will use HTTP with port 80. Click on next. I have to select a specific log group. I'll keep the log retention configuration as is, and I'll click on submit. So load balancer takes a bit of time to complete its configuration. And once the configuration is successfully done, you should see the overall health as okay. So it will check in the backend what all configuration we have provided, what all security rules you have set up, and depending on that, it will monitor the and display the overall health. Now, because this takes a bit of time, I'm just going to pause my video here. So the load balancer setup is complete, and if you see, the overall health is displaying as okay. If you see any warning or critical status, you need to go back and check your configuration, especially around the security lists and the kind of security rules that you have set up. So what I will do is I'll go to backend sets. This is my backend set name, and I'll check the health of the compute instances that form the backend set. So I'll go click on backends. If you see, these are the two compute instances and the health is looking okay. This should be the ideal condition. Now let me go back to my load balancer details. What I will do is I will take this particular IP. I'll put it in my browser, and let's see what message comes up. So it's refreshing. Let's wait for it to complete. Let me see whether the load balancer configuration is completed or not. I'll go to load balancer again. Okay, it is showing active. All the configuration is okay. Let me refresh the page again. Okay, so it is still refreshing. What I will do is I'll just wait for a minute or two just to check whether all the configuration is done or not. So I'll pause my video, because as far as the load balancer is concerned, all the configuration is complete. Let's wait for a minute to basically try out the same thing. Now, ideally, what should happen is when I paste this IP in my browser, it should display a certain message for a compute instance that we have created a server for. So let me just take a pause and come back in a minute, because there could be some configuration that is happening in the backend when we have provisioned the load balancer. Okay, so one of the configuration that I have missed is, if I go to VCN lab, what we have done is we have created a security list for my load balancer, but I forgot to tie that security list to my subnet. So if I go to front end LB subnet, it is still talking with the default security list. I need to map it to the security list that we have created. So I'll click on add security list. I'll remove the reference of this security list from here. And let's see whether it works or not. I'll go to my load balancer again. Okay. And this is my public IP. Close this window. Great. So the issue was that I forgot to tie my custom security list to the load balancer subnet. Now, if you see, it is basically routing the traffic to app2, and this is displayed by the message. Now, if I refresh it, let me refresh this, it is going to app1. If I refresh it again, it is going app2. If I refresh again, it is going to app1. So This is because of the round robin policy that we have created. A load balancer is switching the traffic between application 1 and application 2. So this is how the load balancer works. So depending on the type of health policy, a load balancer policy, and the underlying configuration that you do, a load balancer is routing the traffic. Now, if I go back to my initial diagram that I was displaying, I was routing the traffic to application 1 and application 2 on port 80, and this was unencrypted traffic. Now, in the next video, what we will do is, instead of using this port 80, we will see how to do a encrypted traffic between load balancer and application subnet. And for that, we will use HTTPS and port 443. I hope this video was insightful for you. I hope this gave you a understanding of what the load balancer is, what are the features, and how to set up the load balancer in Oracle Cloud Infrastructure. If you have any questions around it, please drop them in the comment section. Thank you so much.